Mr. K. Balraj is working as a polymer consultant and teaching fellow in the area of polymer science and engineering at CEG Anna University, Chennai. He has completed AMIE in electrical engineering at the Institution of Engineers India, Calcutta, and MTech Polymer Science and Engineering at CEG Anna University. He is also pursuing his doctoral research work in polymer technology. His area of specialization includes polymer rheology, polymer processing, characterization and testing of polymers, polymer blends and composites, and insulation technology. He has in-depth experience on plastic properties, testing methods, and the relevant standards. He has more than 15 years of teaching experience in polymer science and engineering, including instrumentation in polymer industries, engineering plastics, conducting polymers, and rubber technology at CEG Anna University. He has guided more than 30 MTech students in their research projects. He has presented more than 20 research papers in the national and international conferences in the area of polymer science. He has published 10 research papers in the peer-reviewed journals.
Welcome to UGC lecture series in Polymer Science. In Polymer Science, the course is Polymer Processing and Mold Design. This is the fourth part. In the last three parts, we have discussed about injection molding, blow molding, extrusion molding. In today's class, we will discuss about some of the processing methods for processing thermosetting plastics. These are compression molding, transfer molding, and thermoforming. First, compression molding. In the compression molding, normally the thermosetting resin is used. In this, the raw material is placed inside the mold either in the semi-solid form or in the solid form, sometimes as granules or sometimes in a form of a plug shaped form. So, one can have the raw material in different forms. Next, the mold is heated and closed using pressure, and the plastic flows to fill the cavity. Now, here there might be some excess material that will squeeze out from the mold, that will create actually flash. This has to be trimmed away in the secondary operations. So, this is a typical scheme for compression molding, in which you have two parts of the top one and the bottom one. The top one can move, which is to which a hydraulic press is connected, that will provide the necessary pressure for squeezing this material to fill the cavity. And then the bottom mold is normally heated to a temperature near about the melt temperature of the resin. Sometimes this raw material need not be powder or granules. It may be compacted into a shape which is normally called as preform. A preform could also be kept instead of plastic materials in the form of pellets. In the second stage, the top plate will move down. As a result, the molds will get closed, which will result in a cavity in between these two. So, therefore, now the plastic material is forced under compression to flow rapidly around the cavity. Now, heat from the platens, that is this green shaded region, will cause the plastic to cure, resulting in a permanent change in the shape. Now, the resin will take the shape of this mold cavity, which is this one. In the next stage, the component is the top plate is moved up, and then the product is ejected out. And then there might be some flash also, that is nothing but the excess material that may come along with this product, that has to be trimmed. These are the typical compression molded products. The normal thermosetting plastics that are used in compression molding is either urea formaldehyde or phenol formaldehyde. Now, if you look into the products that are made of compression molding, most of the products are related to electrical fittings, and then the handles for kitchenwares, bottle tops. So, these materials are mostly made of formaldehyde based plastics, and these are usually compression molded. Now, high quality finishes are achieved with only the removal of flash. Unless you remove the flash, the finish would be of inferior quality. So, therefore, this trimming operation has to be carried out for products processed by compression molding. Now, if you look into the advantages, why we go for compression molding, the flow actually takes over the short distances. Unlike the injection molding or extrusion molding where the resin is melted inside the barrel, later on it is injected into the mold. Here the material is kept already in the mold, now it is only compressed. So, as a result the flow distance is very less. So, this will ensure that the residual stresses, what we normally call it as frozen in stresses, this will be less. If a product has more frozen in stresses, then that will decrease its tensile properties or the mechanical properties. So, wherever the product has this frozen in stresses, and then to that particular point sudden impact is when the material is subjected to a sudden impact, the product may broke. So, therefore, this is one of the principal advantage. And then looking into the cost, so it is a cheaper and easier mold design, and also maintenance is also very easy. Simply you have to remove the mold from the machine, and there is no gates required unlike the injection molding. So, therefore, this will also result in weak spots. So, weak spots are nothing but the improper cured part of the product that occurs when a resin has to flow for a large distance before it fills the mold. And then no need to design about sprue and runner layout. So, the sprue and runner layout as is a major factor in injection molding, particularly when we go for a multi-cavity mold in injection molding. So, the design of the sprue and runner is a little bit complicated process. So, no such requirement is there in compression molding. Next we will move on to transfer molding. So, the transfer molding actually combines the principle of compression as well as transfer. So, here also thermosetting polymers are used. Thermoset polymers can be formed when a preset amount of material is placed in a separate cavity and heated. So, here like in compression molding, the amount of material that has to be kept in the mold cavity has to be calculated, which is a preset amount. Now, a plunger moves the material into the shaped mold with high pressure. We will see how. Now, why we go for transfer molding means if the part shape is more complex, then transfer folding may be used. Here the charge, which is nothing but the raw materials, the thermosetting plastic in the form of grains or granules or pellets are placed in a heated cylinder till they are soft. So, they are heated and still it becomes soft. Now, a hole at the bottom of the cylinder is connected to the die cavity by a sprue. So, that is how the resin will reach the mold cavity. Now, a plunger will push the semi-solid plastic into the die through this sprue under high pressure. So, this is a typical scheme for a transfer molding. So, in the transfer molding, this is the plunger and this is the transfer pot. The transfer pot has provisions for piston and cylinder arrangement. The housing that surrounds the transfer plot has the necessary heaters to heat this plot. Now, this is the mold cavity and this is the ejector pin. Now, once the material becomes soft, now this plunger moves down, and in the process it will squeeze out this resin through this sprue, and the mold cavity gets filled up, and because it is in contact with the cold surface, this will solidify and then the molded product could be ejected. Of course, the molded product will also come along with the sprue which has to be trimmed. So, therefore, the transfer molding could be viewed as an advanced version of compression molding. Now, the material is heated in a pot or ram and then it is forced into the mold. So, that is why it is called transfer molding. So, this is another scheme or another example for transfer molding where instead of a single cavity, one can also go for multi-cavity mold. So, here also in the transfer in the pot you have the necessary resin in the form of free form. This is the plunger moves and then it squeezes the resin to fill these two mold cavities. These are the ejector pins. Once the products get solidified, the ejector pins will simply remove the product out. So, this is how transfer molding is done. Now, these processes are commonly used with thermosetting polymers like compression molding. Here the initial material could be in the form of semi-solid state, which is partial polymerization, what we call it as pre-polymer, and the heating causes the plastic to set as it forms the shape of the mold. So, normally in the transfer molding process, instead of a monomer or a polymer, a pre-polymer is taken. So, in the pre-polymer state, the polymerization would not have been reached the fullest condition, what we call it as partial polymerization, whereas when the resin is injected into the, where the resin is transferred into the mold, because of heat and pressure, further polymerization will take place. So, the pre-polymer will get converted into a fully cross-linked thermosetting polymer. Now, if you look into the applications for transfer molding, mainly the handles for various kitchenware items like cooking pots, and then housing for high voltage switches, and as some of the rubber parts, elastomers are also being transfer molded like shoe soles, and nowadays even composites made of the fiber reinforced parts are prepared using transfer molding. Next, we will move on to thermoforming. The thermoforming, as the name itself implies, the thermoheat, the heat is used to form the shape. The thermoforming method consists of heating a thermoplastic sheet, then sticking it firmly on top of a mold to shape it. So, here unlike when the difference between the thermoforming and the other processes, instead of plastic resin in the form of granules or pellets, here plastic sheet is taken. Mostly it is taken in the form of a sheet molding compound. Now, it is passed through a heating arrangement where it will get softened. Next, it will passes through the mold, and then it takes the shape of the mold as like here. Then a cutter is used to cut as per the requirement, and finally the product is ejected out. So, this is how thermoforming is done. Now, if you look into the definition, this thermoforming is the process of forming a thermoplastic sheet into a three-dimensional shape by heating it to render it become more soft and formable, then applying different vacuum and pressure to make the sheet conform to the shape of a mold or die. That is, as and when the thermoplastic sheet is passed through the mold, a vacuum or a high pressure is injected inside the mold. As a result, the thermoplastic sheet will take the shape of the mold. Now, looking into the difference, how it is different from the other plastic fabrication process, here the raw material is not the usual pellets that is being melted through the use of extruder, because in the extruder, in a single spool extruder, what you have seen earlier in the extrusion molding, in the hopper it is fed with polymeric materials in the form of pellets, and then it is melted to produce the desired shape using a die or mold. But here a finished product like a sheet extrusion. So, therefore, for thermoforming involves the raw material which is already the finished product from the sheet extrusion molding machine, which is normally in the form of rolled sheet. So, if you look into the main process behind any thermoforming machine, because there are lot of types of thermoforming which we are going to see shortly. In all these are the 6 main processes that involves this thermoforming. The first one is the unwinding or unreeling of the sheet roll. As we have seen earlier, the raw material for the thermoforming is not a pellet, instead it is a sheet roll which is normally winded over a drum. So, therefore, it would be unwinded and then it will pass through. Now, the sheet is unrolled to dispense the material into the feed zone. Using a guided chain, the sheet is conveyed and is passed through the heater. So, now the sheet roll has to be subjected to heat, because then only it will become soft. Only when it is soft, when a vacuum is applied inside the mold, it could sheet like material would take the shape of the mold. The second process is the heating. Now, the sheet is heated to make it soft and also at a set parameter. So, the parameters has to be set clearly based on the type of resin. The third one is the forming process. Here the shaping of the sheet roll into the mold shape would take place, and also it will be subjected to cooling, thereby the liquid resin will get solidified, and hence it becomes hence it takes a solid shape. The soft sheet is formed to the shape of the mold, and then it is allowed to cool. And the next step is the cutting. So, the molded product is separated from the runner or skeleton. So, it is one of the main drawback with a thermoforming process, wherein you will always encounter with a runner or skeleton. This has to be trimmed off to separate the product. And the next stage is the stacking. The product is collected in a stack and then ejected to the conveyor for packing. So, these are the secondary operations. And finally, the winding of the skeleton. The skeleton is collected and it is removed, and it is collected and removed for recycling. The same skeleton can be again reused, that is, it can be again converted into a sheet roll, and then it can be used as a raw material for this thermoforming process. So, this is the picture depicting all the 6 processes what we have seen. The first one is the unwinding of this sheet roll. The unwinding takes place, you will have provisions are there here, the guide pin that will ensure that the sheet roll just passes through in between the 2 heaters, where it gets soft, then it passes through the mold, and then it takes the shape of the mold. Then this is what is called as the skeleton or the runner, and this is the actual product. So, the actual product will get collected at the stack, and then this runner has to be trimmed off actually, and then recycled. Now, what happens in this mold, which is the main focus of this thermoforming process, which is nothing but the forming. So, this forming process we will see in the next slide. So, this is what happens inside the mold. As the resin passes through this mold, a forming takes place by either means of a vacuum, then it is called vacuum thermoforming, or by means of a pressure or pressure thermoforming. In either case, a strong force that will pull the resin towards the mold, and then once it comes in contact with the mold, it gets cooled and then it gets solidified. So, that is how the shaping takes place. Now, if you look into the advantages of thermoforming, the equipment is cheap, and also the mold cost. Both the compression and the compression molding and the thermoforming process, the cost of the mold is relatively cheap compared to injection or extrusion molding, and then higher productivity is possible. This can be run, the thermoforming process could be run as a batch process or a continuous process. So, high productivity is possible due to its high speed, and then thinner wall product is possible, therefore, lesser material consumption and cheaper products, therefore, products of affordable range could be produced. And again, because of all these factors, the production cost is less. Now, if you look into the disadvantage of thermoforming, the disadvantage is only the high scrap rate due to its inevitable runner being generated as part of the production process. As we have seen earlier, the runner or the skeleton that comes out along with the product, this has to be trimmed and then it has to be recycled. So, it has to be, the runner or the skeleton is softened 2 times, one time for the during the thermoforming process, the other time when you want to again reuse it, you have to prepare it as a sheet, there again you have to melt it. So, therefore, that is the only disadvantage with respect to thermoforming. Now, if you look into the properties required for plastics or polymers that could be used for this thermoforming process, the first requirement is the good hot elongation. When it is in hot condition, it should not break, rather the melt has to be continuous and it should elongate. A typical elongation percentage required is 500 to 600% elongation is required. Next, good strength at hot condition, that means that is characterized by a term called heat distortion temperature, HDT. So, heat distortion temperature is the temperature at which the material does not deteriorate at a rated temperature. So, therefore, this HDT value when it is not under load or when it is under load should be high, because the material is subjected to high vacuum or high pressure inside the mold when it is at hot conditions. So, therefore, the material should not distort. So, this is another requirement. and a low hygroscopicity, that is it should not absorb any moisture. If it is the material is going to be hygroscopic, then drying the sheet is necessary. Before the sheet is unwinded and passed through the heater bands, it has to be dried first. That will escalate the cost of the process. So, therefore, generally preferring a material that will absorb less moisture or that will not absorb moisture at all is the ideal material. If you look into the type of plastics with respect to amorphous the plastics, all styrene compounds or styrene based copolymers like ABS, acrylonitrile butadiene styrene could be thermoformed, and then acrylics mainly PMMA, and polycarbonate and its copolymers, and plasticized PVC, not rigid PVC, plasticized PVC could be thermoformed, and also polycarbonate and polyethylene terephthalate blend. This is one of the commercially exploited blend which has more wide application with respect to products that are made of thermoforming process. And when you look into a semi-crystalline material, all polyolefins, polyethylene, polypropylene could be thermoformed. And nylons are known for its hygroscopic nature, that is it will absorb moisture at room conditions. Therefore, whenever nylons has to be thermoformed, then special thermoformal grades are available, and that could be used for this thermoforming process. Next, we will move on to types of thermoforming. There are actually many thermoforming processes available in the market, but then all these belong to any one of these three, or in other words, the three most commonly used process are called vacuum forming, pressure forming, and plug assist forming. So, this plug assist forming is again a subdivision of vacuum forming. So, therefore, the two main types are only vacuum forming and pressure forming. First, we will look into vacuum forming. So, this is the oldest method and cheapest method in terms of the equipment cost, because the only provision that is required is creation of vacuum inside the mold. So, this is the earlier method. Now, the next method is the pressure forming process. So, this is the fastest method in terms of production speed, because high pressure, if you increase the pressure, then the production rate could automatically increase. That means the resin will take less time to take the shape of the mold. So, typical speed is 3 times that of the vacuum forming. So, therefore, whenever high production rate is required, then people go for a pressure forming process. The plug assist forming process is again a variation of this vacuum forming process, where deep draw shapes are required, like drinking cups or bowls. These are the products that involve certain depth. In such cases, we go for plug assist forming. Now, if you compare the difference between the two main types, one is vacuum forming, another one is pressure forming. This vacuum forming uses a vacuum to suck the sheet flat against the mold. So, as you could see, so this is the plastic resin in the form of a sheet that will actually clamp it within these two. Now, a high vacuum is applied inside the mold. As a result, the resin will try to take the shape of the mold. So, this is how vacuum forming is done, whereas in the pressure forming, instead of vacuum, it uses pressure to press the sheet flat onto the mold. So, you could see here, instead of vacuum, there will be a very high pressure that will in fact applied on the top end, that will push the sheet shaped plastic resin to take the shape of the mold. Looking into the materials used in vacuum forming, many types of thermoplastics are suitable for vacuum forming. The most popular one is the high impact polystyrene, which is commonly called as HIPS. So, the difference between the polystyrene and the high impact polystyrene is, so in the polystyrene is the presence of bulky groups in polystyrene makes the material so brittle. Now, if it is embedded with some elastomers on the surface, which will efficiently transfer any impact on it, its impact strength could be increased. So, that grade is called high impact polystyrene. The reason why we go for HIPS in the vacuum forming process, it is relatively cheap, and then it is very well adaptable to color additives, that is different colors could be added as an additive, that is a good mixing of color additive with respect to HIPs is possible, and also it could be easily formed. So, these if you look into the products using HIPs that are processed with the help of vacuum forming process, it could range in size from garden pond liners to food trays used in supermarkets. So, therefore, wide range with respect to the size is possible. Next, moving on to the types of vacuum forming, again based on the orientation it is called straight forming or drape forming, snapback forming, air slip forming and plug assist forming. We will see some of the common types. Before that, in the vacuum forming what happens is, this is the typical procedure involved in the vacuum forming process. First a thermoplastic sheet is clamped over a negative mold. So, usually the bottom mold. Now, the sheet is softened by heating. Next, heat is applied so that the plastic sheets get softened. Now, vacuum is drawn within the mold through vents. So, vents are provided at the bottom of the mold through which a vacuum is applied. As a result, the sheet is drawn into contact with the mold and it is allowed to cool. Once the sheet is cooled, it can be removed from the mold. So, this is a typical scheme. This is a typical scheme for vacuum forming process. This is the negative mold or the bottom mold, in which the heated thermoplastic sheet is clamped firmly, and these are the vents through which vacuum could be applied, and this is the mold. And then in the next step, the vacuum is applied, this sheet shaped softened thermoplastic sheet would take the shape of the mold like this. The another variation is here the plastic sheet is again clamped and it is subjected to heat. Instead of a heated thermoplastic sheet, a sheet is placed and over which a heater is provided, which will provide the necessary heat energy for this sheet to melt, to get softened. And now, the second stage, heat is removed and then the pattern will be raised, and then vacuum forces the sheet onto the pattern, and then the sheet is removed and trimmed. So, in the first stage, the plastic sheet is clamped and then heating is provided. A heater will be on, and in such a way this plastic sheet would get softened. Next, the heater will be removed. So, this is the mold and these are the vents, and this is the evacuation pipe to release the air out. Now, once the vacuum is applied, the resin will take the shape of the mold, and then finally the product is ejected. So, this is how a typical tray what is found in a supermarket, or the chiller, the ice making chiller, ice making plastic unit that is used normally in the refrigerator to prepare ice cubes. These are normally prepared by vacuum forming. These are the other different types of thermoforming: plug assisted vacuum forming, billow forming and vacuum snapback forming. To summarize, in today's class we have seen how a plastic product is made of compression molding. Normally thermoset materials are used in compression molding, and then the transfer molding combines the principle of compression as well as transfer. In both the cases, the mold cost is less, that is why people go for these two type of molding processes. And then we have discussed about thermoforming. As the name implies, thermo heat. So, heat is used to shape the product, and in the thermoforming we have seen different types and its applications. So, mostly there are two types. Mainly there are two types in thermoforming. One is vacuum forming and another one is pressure forming. After looking into this episode, the viewers should try to understand and answer these questions. What is compression molding? State the advantages and disadvantages of compression molding over other molding processes. Also compare compression and transfer molding. What is thermoforming? Describe the different types of thermoforming. Thank you.